Hello and welcome to the Calculator Guide video on calculating resultant forces on a Casio fx-991CW. Let's take a look at the first question. Two forces P and Q act on a particle as shown. P has a magnitude of 12 newtons at an angle of 45 degrees above the horizontal, and Q has a magnitude of 10 newtons at an angle of 35 degrees below the horizontal. Work out the magnitude and direction of the resultant force. Let me just say from the outset that this is just a possible method to be able to work out the resultant force. It isn't the only method and it might not be your preferred method. It is just an option for you. And we're going to be using complex mode on the fx-991CW, even though we're not actually dealing with complex numbers, but there is a feature within there that will be able to help us calculate a resultant force. So from home, we're going to navigate to complex and select that. Now you may have an I displayed here depending on your default settings, and we will need to change that, and I'm going to show you how in just a moment. Double check also that your angle unit is in degrees, as we have the angles given on the diagram here in degrees. From settings, go to calc settings and then navigate down to complex result and select that. And then what we want is to change from the top option here, which is the general form of a complex number, to the polar form of a complex number. So R and then the angle theta. So we want to select the bottom option, press OK. And when we return to the input screen, you can see there that it's changed to an angle rather than an I, indicating that we can input complex numbers in polar form. Let's start with the first force that we have. Input 12 for the 12 newtons, and then in order to get the angle symbol that we saw there, it's catalog, complex, and then we want the angle symbol there. Then we want to input the theta. We're taking the positive horizontal, the positive x-axis or the positive I vector to be 0. We will input angles anti-clockwise relative to that line. So we've got 45 degrees above the horizontal, so that's a positive 45 degrees. Now we're looking for resultant force, so we're going to add these forces together, so plus, and then 10 newtons, and again we want the angle symbol, catalog, complex, and then the angle, and then we want theta. Well, this is below the horizontal, so I'm going to input this as negative 35. Alternatively, you could input this as 360 minus 35, 325 instead, which would be the reflex angle going anti-clockwise. It's up to you, really. I'm going to input that as negative 35. Let's press execute to process that. And let's have a look how we would read this answer. So the first value that we have here, 16.9 and so on, is the magnitude of the force. So the magnitude is 16.9 newtons. And then the angle that we have here is the angle relative to the positive horizontal. So it's positive 9.36 degrees. So essentially it's 9.4 degrees above the horizontal x-axis or above the positive I vector. Incidentally, if you did want that broken down into horizontal and vertical components of the resultant force, what we can do is press Format and then select rectangular coordinates and press OK. We have the first value here, 16.6 and so on newtons. Well, that is the force in the I direction, the X direction, plus 2.749 and so on is the resultant force in the J direction or the Y direction. And so it's broken down there into horizontal and vertical components if so needed. Let's have a look at the second question here. Three forces act upon a particle in the diagram below. Given that the particle is in equilibrium, calculate the magnitude of F3 and the value of theta. Now, in this particular example, we have an unknown, so we have to just think slightly differently about how we might input this into the calculator. If we think about the 15 Newton force as, say, being F1, and the 20 Newton force as, say, being F2, then what we know is F1 plus F2 plus F3 equals 0. Why? Because the particle is given as being in equilibrium. So a slight rearrangement of this could be F3 equals 0 minus, and then in brackets, F1 plus F2. So essentially 0 subtract the other two forces added together will equal the remaining force, F3. And so we're going to input it into the calculator as such so that we can find our missing force and angle of direction. So it's 0 minus, open a set of brackets or parentheses, and then the first force, let's say F1 is 15 newtons. Catalog, complex, and then the angle symbol, we want to input theta. Now, once again, we want to do this relative to the positive horizontal direction. So I'm not going to input 40, I'm going to input 180 minus 40 degrees, which is 140 degrees. Once again, it's adding these forces together, so plus, and now the 20 Newton force, catalog, complex, and the angle. Then, well, we've got two options on the second angle here. Again, we want it relative to the positive horizontal. I'm going to input this. In fact, I'm actually going to do it as a calculation, just to show you that you can do that if you're not sure. In brackets, just so the calculator recognises this as being theta, 180 plus the 55 will show the reflex angle that goes anti-clockwise from the positive horizontal. Potentially, you could input that as negative 125 degrees as well, which would refer to the force travelling in the same direction. So close that bracket there and close the second bracket to contain our F1 plus F2. Press execute. And let's have a look at the answer that we have now. While the resultant force would be 23.9 and so on newtons, and the angle that it would act at is 16.36 degrees. Now that's positive, so that's 16.36 degrees above the horizontal. Again, if we want to break that down into horizontal and vertical components, it's format and rectangular coordinates. We've got 22.96 in the I direction, in the X direction, plus 6.74 in the J direction or the Y direction. So there we go, how we can use complex mode and the polar coordinates to have different methods of how we can solve questions with resultant forces. Once again, I would just stress this is just a possible method, a convenient method to be able to use to be able to solve problems with resultant forces. It isn't the only option. Don't forget to like and also subscribe for future videos. But that's it for this video. Thank you very much for watching, and I shall see you next time on the Calculator Guide.